Well, I got the kiln all wired in. I fired it up. It's working good. I got it on the wheels so I can move it around. So what I'm thinking is going to be a good first test. I don't remember if I ever put this on video, but I made this crucible. I don't remember what this is. I'm not sure if this is Inconel or something along those lines, but I just remember it was a heavier steel. I welded the bottom and I put a couple of handles on it. There's aluminum inside here that I was messing around with. So what I think I'm going to do is I'm going to put this in the kiln. I'm going to crank up the kiln, and I just want to see if it gets to a molten state. That's it. Nothing fancy, nothing major. Just to mess around with it as a first time and go from there. One of the first things I'm going to do is I'm going to design a digital timer display so I can set like a ramping feature for this machine, because right now it's just on an old-fashioned timer system. I mean, which is fine, but I could do so much more with it. Anyway, stay tuned. I'll take you along for the journey. I'm just going to show you guys real quick what it looks like now that it's getting heated up. Whew, that's hot. Alright, I took it out. It melted perfectly. Obviously, I didn't pour it or anything. I just left it in there. I'm going to mess with it later. I'm going to try to drill it and see if it's solid. Kiln worked perfectly. It took about an hour, maybe an hour, 15 minutes to get up to temperature to melt that. I will say it's not as insulated as I hoped. You cannot touch the outside of this thing. It is hot as hell. So I don't like that. So I might save this for, outside stuff. I can just wheel it right out the door here. It generates a lot of heat. I'm sweating my butt off here. And it's actually a really cool night. So, I mean, maybe in the winter it won't be so bad. I could just crack the garage door and let some of the cold air in, but for now, this thing is way too hot. But that was it. Well, I guess one other thing I wanted to show you guys. She's alive. I'm getting the axes all set up now. It's all wired in. The box is all attached. I'm not sure what I did, but X, Y, and Z isn't exactly correct. So I'm going through it now, fine-tuning it. I'm going to get this finished, painted, and then I'll get the video up and done for you guys. But stay tuned. This is a motor mount that I'm designing for the lathe. I'm going to use a treadmill motor to power the lathe, which should be a heck of an upgrade from the original motor. I believe the original motor is something like 500 watts, so it should definitely be an upgrade. This is the motor here. That I'm using. It's a 2.9 horsepower, 8,000 RPM, 130 volt motor. Let me show you the one that was on the lathe. This was the one that was on there. Whoops. 3/4 horsepower, 5,000 RPM. I mean, for the most part, they're close as far as diameter goes. Obviously, this one's a little longer, This one's 110 volt DC. But again, I'm gonna go with this one here because I'm gonna gear this down. I mean, come on, 8,000 RPM on a lathe, that'd be suicide. And so that'll also give me a lot more torque. Now, I had to make a motor mount for this. I think it's kind of funny. This has 2 studs, and wouldn't you know it, this has 2 studs. Of course, they don't line up or anything, but it wouldn't matter anyway since it's going to be a different setup. This is the motor mount that I came up with. Now basically that is going to go over this. It will have a center bolt to hold the mount to the motor, and then this part here will be threaded. This will hold the motor mount to the bottom of the 1-inch thick plate steel. What I'm going to end up doing is basically a pillow block bearing setup where you've got a shaft with two pillow bearings. This will turn the pillow bearing shaft, and then the pillow bearing shaft will turn this. That way, to me, it seems to be the easiest way to gear this down. I'm going to gear it down 4-to-1, so it'll be, I should get 2,000 RPM off of this, and that'll increase the torque, 4 times. So should be more than enough for anything I want to do for the mini lathe. I'm more concerned about the threading, obviously. But I did make a little bit of a mistake on the mounting plate. Let me show you where I'm at with that. Okay, this is the mounting plate that I designed. You'll see some little blemishes in the steel. Ignore that. I'm using scrap pieces of scrap that I've had laying around. So some of them, have been pre-drilled or whatever. Now, what I did, unfortunately, let me show you. This has 3 holes to mount the spindle housing to the frame, and you'll notice they're not centered. Of course, I didn't notice that when I lined everything up and measured it, and I centered them all on this plate. So that's the first problem. When I line this up, you get this overhang over here and this overhang over here. When I was anticipating this just being, otherwise it came out perfect, width-wise and lengthwise. So yeah, back to the drawing board for this plate. But so you could see what I was talking about, these will bolt down to this. So essentially, there we go. So essentially, this will sit on top of this plate and be bolted to it. And now these bolt holes will bolt this down to the frame. I'm going to have to notch this out for a drive belt. It's either going to be that or, you know, find another way to drive it. As of right now, I'm just planning on using this. It works, and, you know, I think I can make it easy enough. So, took a little bit of a hit, but that's where I'm at now. I started making the motor mount on the mill. You'll see the video of some of that. I'm gonna have to remake this plate, which, you know, is what it is. Live and learn. Nothing I can do. But we're making some headway. This is it. Just wanted to show you guys where I was at. All right. These are the pillow block bearings I'm going to use for the lathe. This is a 1-inch ID for 1-inch bar. I'm going to use this along with the motor and the belt pulley system to do the gear reduction. This should be plenty heavy duty enough. This is the CAD program I've been working on for quite some time now for the lathe. This is gonna hopefully make my life easier when the time comes. So you saw how I made a mistake with the plate. I'm hoping if I do this properly and I take the time to, you know, put everything in here, it'll show me ahead of time if I'm going to have a problem. Of course, I know there's always, you know, the ins and outs or whatever, but, you know, in any case, this is going to be more helpful. Don't mind the feet here. It's just I'm designing the way to hold this at an angle, because this will be at an angle. This is the spindle mount. This is the 6-inch chuck. This is the Aloris tool holder here. Basically, what I'm trying to estimate here is the height to the center of the chuck line, and I need to know that because I need to know the distance of, well, basically the thickness of this plate. And I need to know how to put the motor. I'm gonna guess that this base is not gonna be used. I'm gonna use that 6-inch piece of plate steel you saw, and then I'm gonna build off of that. And down here I will put the shaft with the pillow block bearings and the belt coming up to here to turn the spindle, the spindle. But we're making headway. I think we're doing pretty good. It's going to take a little longer to get this program finished, but I think so far it's looking good.